The first 4 problems on our practice sheet today is just a refresher of how to factor. Number 1, they want us to solve by factoring and then use the zero product property. We've been doing that for a while before the break. So let's go through the checklist. Number 1 is the a value 1 on our checklist, or on this puppy. It is a quadratic. It's equal to 0. Is the a value 1? Yay or nay? That's a nay. Number 2, is there a GCF that we can pull out? Yeah. Because there's no c value, right? Doesn't every one of these terms on the left side at least have an x in it? How about numbers? Can we pull out some numbers also? Doesn't 4 go in each one? So we can pull out a 4 and we can pull out an x. Get that done for me. We good with that? And now there's no more quadratics left, so we just use the zero product property to solve. What value of x would make the first guy 0? And he counts because it's got a variable in it. Sometimes there's just a number out there. We pay no attention to the number, but if there's a variable out there, that's good. Or now I'm going to try to set us up for what we're going to do today. What value of x would make this guy 0 if x was what? And we are very good at that because isn't it the opposite of this guy over that guy every single time, right? It's the opposite of this guy over that way. So then solution set 0, 2/3. Next guy, go for it. First move is to get it equal to 0, right? Is the a value 1? Nope. So is there a GCF you can pull out? Nope, x doesn't go in everything, numbers, no good. Is it a difference of squares? Is it even possible for this to be a difference of squares? Why not? There's differences going on. It's 3 terms, right? Difference of squares is only 2 terms. Is it a perfect square trinomial? First guy's not a perfect square, so that throws that out. That means a roundy face time. A roundy face. I'll let you roll with pal. Help each other out. So then, if 3 and negative 8 are our 2 numbers, 6x squared, I like the negative to come first. It doesn't have to come first. We split it into the 4-banger. Cool. Then double group. You can pull a 2x out of this and get a 3x minus 4. I can pull 1 out of that because there is no GCF, but you got to pull 1 out. So I'll pull a 1 out and I get a 3x minus 4. Good things happen because I got the same thing twice. Now I will regroup of a 2x plus 1 times a 3x minus 4. And now I use the zero product property. What value of x would make that be 0 if x was opposite of this guy over that guy, correct? Or 4/3. And what I like is we are getting more comfortable with it. Again, this is my opinion, but this is the hardest part. Finding the 2 numbers is the hardest part in my opinion. Once you have that, it should be a gravy train at this point. Cool? Next one, go. Just for memory. 24. When these multiply together to be a 24, that means one negative number is out. They either both have to be positive or both have to be negative. What is the sign in the middle guy? It's negative. That means that both of the numbers have to be negative, and that to me is a negative 2 and a negative 12. Don't those multiply together to be a positive 24 and add together to be a negative 14? So we set it up. Order doesn't matter. Anytime, especially when they're both negative, order really doesn't matter. Double group, boop, boop. Keep that negative there and throw a pluser in between so it doesn't look like you're multiplying those puppies together. Pulling out a 2x in this one, and I'll get a 4x minus the uno. Then I have to take out a negative GCF in this one. Because this first term in this parenthesis is negative, I got to pull out a negative GCF. It looks like shui goes into both of those. Negative 12x divided by a negative 3 is a positive 4x, and 3 divided by negative 3 is a negative 1. Regroup. 2x minus 3, 4x minus 1 equals 0. All cool? So x could equal 3 halves or 1/4. all concepts that will make this chapter we are about to start today move smoother. One last guy, talk yourself through the list. Takes a while to find the two numbers. It is a frowny facer. 144 was our product. 9 and 16 were those two numbers. Hey, question for you. See these? Are those conjugates of each other? Those conjugates of each other? 3x plus 4 and a 4 plus 3. Are those conjugates of each other? What are conjugates of each other? That if this one's a 3x plus 4, the conjugate of 3x plus 4, 3x minus 4. It's got the exact same thing minus the signs. Cool. So what we do now is write a quadratic equation in standard form, which looks like this: ax squared plus bx plus c equals 0, with the given roots. These are the answers to the problem. We want to go backwards. Didn't we get two answers right here? These are the two answers. Now we will go backwards and write these two puppies right here equal to 0. Then we will FOIL it out, and we will get this for a final answer. So if these are the two answers, got a question for you. Are they fractions or are they integers? Real easy then. Isn't it like this? If these were the two answers, just check this out. I'll guarantee you that it looked like this before we solved. If we think backwards, isn't it kind of like the old opposite game in the parentheses? Since we got nice, neat, whole answers, the number in front of x was a 1. That came out to be a positive 3. So do you see how I put a minus 3 in front of it instead? And then this was a negative 4. Isn't it the old opposite game? Write that down. We need to do that next. We're just going backwards, friends. It has been factored. We found the answers. Cool? They want it in standard form, though. Is this in standard form? FOIL it out. Is there a shortcut to foiling this situation out? Is this a binomial squared or a conjugate situation or anything like that? So you got to FOIL it. First terms times each other would give you an x squared. Outside guys times each other. Inside guys times each other. And last terms times each other. And it's still equal to 0. How come we're making it equal to 0? Like, why is the equal 0 there? These are the solutions, aka the roots to this. The only thing you can have solutions to is an equation. So it's got to be equal to 0. Are there any like terms that we could combine? So x squared plus, how many x's are in the middle? Good deal. If I ask you to factor this, what's the a value? It's 1. Meaning your job would be to find two numbers that multiply together to be negative 12 and add together to be 1. I'll bet you that those two numbers that you find would be a 4 and a negative 3. Don't those multiply together to be a negative 12 and add together to be a negative 1? So if you'd factor it, you'd have factored it into this. If you'd solve it, then you'd solve it and get x equals 3 or x equals negative 4. What we are having here is this is where the parabola crosses the x-axis, trying to set you up for the future here. The parabola, look at it right here. Can you tell me if this parabola opens up or opens down by this equation? Open up or open down? Opens up, because isn't the a value a positive 1? It's going to cross the x-axis at 3, and it's going to cross the x-axis at negative 4, and it would look like so. Those are the two solutions to that quadratic equation. It opened up because we know the a value is 1, and etc. So number 6, if these are the solutions, what are my two groups going to look like? Since those are integers, what would be my first one? X plus 8 times the quantity of x plus 2 equals 0. Now, since they want it in standard form, FOIL it out. Is there a shortcut to that one? Nope. And if you think backwards, two numbers that multiply together to be 16 and add together to be 10 are 2 and 8. It's the opposite of those situations right there. Is that all good with you? Quadratic situations, though, have to have two roots. They have to have two roots in theory. Number 7 says it crosses the x-axis at 6 in one place. We've done a bunch of those to where it crossed the x-axis in one place. They look like this every time. Would you all be cool with that's one of the parentheses that we're going to have right there? But there's supposed to be two of them. In theory, it should look like this, but I don't want to write this. I don't want to write that. I just don't want to write that. Is there an easier way to write x minus 6 times x minus 6? When you have a perfect square or a binomial squared situation, you're only going to get one answer out of that situation, correct? You're going to get 6 out of that situation. So when there's only one answer here, you know it's got to be a binomial squared situation. So they ask us to write it in standard form. We need to expand that. Is there a shortcut to expand this? What's the first move? Square the first guy. Then twice the product. What is the product of those bad boys in there? Negative 6x. I need twice that, so negative 12x. And then what's the last guy going to turn out to be? You squared the last dude. And is it a positive 36 or a negative 36? Because when you take a negative times a negative, you get a positive. And there we go. Hey, one answer on number 8, correct? What's it going to look like before I even get started? What will it look like? It looks like a binomial squared. Set it up for me. It looks like a binomial squared. Will it be x minus 5 or x plus 5 in the parentheses? The opposite game. Quantity squared equals 0. Then expand it out with the shortcut. All good in the neighborhood? Tell me what these things are called right here. This guy and this guy. What are these guys called? You better hurry. What are those guys called? X squared plus 10x plus 25. X squared minus 12x plus 36. Say that louder for me. Perfect square trinomial situations. Perfect square trinomials. Next. Ooh. Ooh, ooh, ooh. There's our two answers. X equals 0 or x equals negative 1/3. Correct? First guy. If we put it in parentheses, would we write x like plus 0? Would we really do that? Or x minus 0? It's like, aren't you supposed to? Do we write x plus 0? What does that mean that the first dude times it is going to be, if the answer was 0, it's going to be what? Just an x. Cool. The second guy, though, is a fraction. When we got a fraction for all our answers, back in time, see all these crazy fractions when we got them? We got a negative 1/2 here, we got a 4/3 here. Weren't they real simple to find those fractions when we did it? Because wasn't it like the opposite of this guy over that guy? Wasn't it the opposite of this guy over this guy? So which dude is in front of the x every time? Is it the numerator of that fraction or is it the denominator of that fraction? Isn't this the denominator of the fractions, correct, right here? And the numerator is these guys' opposites, correct? So if we go back to where we were, I need an x to lead off with, but what's in front of it? A 3, right? Isn't that the denominator of this one? And then doesn't this say minus 1? But I want the opposite of that guy, so what would I put? Plus 1. Now double check. Make it equal to 0. Check to see if you'd get those two answers real quick. If you'd solve this, what value of x would make this turn out to be 0? 0. What value of x would make that turn out to be 0? Negative 1/3, correct? So we're just going backwards. It's the old opposite of this guy over this guy trick. It's this guy leads off, and I need the opposite of that guy over there, and don't forget the variable. Now, expand it. Do you FOIL this situation? Well, why not? How come you can't FOIL it? Binomial squared. You can FOIL things that are not binomial squareds. In the ballpark, though. Like we FOILed this, right? How come we could FOIL this? And how come we could FOIL this? And you could actually FOIL this if you wanted to, but there's a shortcut. What's the only thing that you can FOIL? Binomial times a binomial. Is this a binomial times a binomial? Is the green thing a binomial? The green thing, is it a binomial? Is the red thing a binomial? What is the red thing if it's not a binomial? How many guys are there? One. Not called a trinomial, that's 3 terms. Not called a binomial, that's 2 terms. What's a one-term thing called? Monomial. I think you've been doing it since Algebra 1 to take a monomial times a binomial. What do? Use the distributive property. Oh, yeah? Feeling okay with that? Next guy, got a fraction again. Let's set up this first dude. Which one of these is in front of the x? Is it the 5 or is it the 4? The 4 is. There's an x with it. And then since that's a positive 5, this be right here. A minus 5. It's the old double check. Is it the opposite of this guy over that guy scenario when you get that 5/4? You all with me on that? So how about my next one? What would I lead off with this? A 2x and then plus 1. Don't forget the equals 0. Is that all good with you? Now expand it. Can you FOIL this one? It's a binomial times a binomial. That's how we'll do it. Is everyone cool with that? Yeah. Now watch this. Let's pretend I ask you to factor this. Is the a value 1? Yes or no? Nope. Is there a GCF you can take out? Nope. Is this a difference of squares? Nope. Is it a perfect square trinomial? Nope. So it's frowny face. What did those two numbers multiply together to be? Negative 40. Find two numbers that multiply together 40 and add together to be negative 6. Wow. It's a 4 and a negative 10, isn't it? It's a 4 and a negative 10. It's the same thing that we did backwards. Factoring is FOILing in reverse. You unfoil, you unfactor. Next one, get it done. Set it up, expand it out, etc. Yep, that's a 3x minus 2. Next guy is a 3x plus 2. What do we still need? Equals 0. What are these called? Conjugates. If you don't remember the shortcut, FOIL it out and simplify it. If you do remember the shortcut, when you do the FOIL process on conjugates, tell me about the outside guys and the inside guys every single time. They add up to be 0, meaning all you got to do is take the first terms times each other and the last terms times each other, and you're done. What, oh what, is this thing called right here? This is a difference of squares. What, oh what, are those things there? Conjugates. One more. Get her done. So you should have got this for a final answer. Let's go to the next problem. You'll see these on the ACT, left and right. A bunch of you have taken the ACT already. See if it jogs your memory. The height of a javelin in feet is modeled by that function. What kind of function is it? It is quadratic. How come? Biggest exponent you see is a 2. Will this parabola open up or open down? How did you know it opens down? And if I throw something, here's my javelin. Here's the ground. Here's my arm right here. It went up and then parabola that opens down. How come when things go up, they here on Earth? Gravity. This is a tremendous real-life situation. We are getting better and better and better and better and better and better at it. They said, here's the function. T is time in seconds after the javelin's thrown. How long is the javelin in the air? This is the hardest part for y'all to understand. How long is the javelin in the air? So here's me. Again, I throw it. It is released. Is it in the air? Yes or no? Right now, after I've thrown it. Yep, in the air, 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 in the air. Boom. Is it still in the air right there? No. Was it in the air this entire blue time, though? I would like to know how long it was in the air. Well, isn't this the x-axis right here, which is time in seconds? Like if we was to make a graph of this situation, the x-axis is time in seconds. And we'd like to know until it hit right there. This is the height of the javelin in feet. How high is the javelin in feet right there? It is 0 feet high. Hasn't it hit the ground? So I would like to know where this particular point is, which is an x-intercept. And to find the x-intercept, you let y equal how much? And we don't have a y, we got a h of t, right? Same situation. But what do we want to do for this problem to solve? We want to know when the height of this thing is how much? It's 0. So let's put 0 into this function. Let's do that. 0 equals negative 16t squared plus 79t plus 5. And then we'll show you some secrets. Nobody really likes to factor this one. There's something just a little bit different from all the previous ones. It can be done, like don't get me wrong. It can be done, but something's different about this one than all the other ones. And don't tell me that the zero's on the left instead of on the right. Who cares about that? What's different about this one? A value is negative. The first number is negative. We have factored hundreds of problems to this point, and the first number was always positive. Correct? Once again, we are trying to find, in general case, where a parabola crosses the x-axis. See this guy? How does it open? Up or down? Up. Well, you know what? If I change all the signs, here's what it would do to that parabola. It would make it do this. Instead of open up, wouldn't it open down instead? Correct? Where does it cross the x-axis at, though? In the same spot. If you do this magic trick, take everything times a negative 1, all that we'll do is take that parabola and change the openness of it. Instead of open up, it'll open down. Or if it open down, it'll make it open up. So if we distribute, what's negative 1 times 0, baby? Still a 0. Doesn't it just change all the signs in this situation? You are free to do that if you like, to change all the signs. It did affect the parabola. It now opens up instead of opens down. Will it still cross the x-axis in the same place, though? Yes. So let's see if we can factor this. Well, let's go through the list. Is the a value 1? No. Is there a GCF that we can pull out? No. Is it a difference of squares? Is it a perfect square trinomial? First thing? Yep. Last thing? Nope. Frowny face. Go for it. Da, 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 da. What is 16 times negative 5? It's not 80. What's 16 times negative 5? It's negative 80. Awesome. Find two numbers that add up to be a negative 80, excuse me, multiply together to be negative 80 and add together to be a negative 79. Awesome. That's real easy. What are those two numbers? You're going to use a 1 and an 80 combo, right? But one of them has to be negative. Which one's got to be negative? Factor it. Please put a tail on your t's so they don't look like ones. Or, excuse me, pluses, I mean. Put a tail on your t's so they don't look like plus signs. I don't know why I pulled a 4 out. Put that 4 there. Now that you have a little more factor experience, would you like to see a real easy trick to see what's the GCF between the first two guys? Look at the last two guys. What's that one? It's a t minus 5. Shouldn't the first one have to turn out to be a t minus 5 after you've taken the GCF out? So what would you have to do to this guy to get it to turn into a t? What would you have to take out? You'd have to take out a 16t, wouldn't you? And if you do that, you'd get a 1t right here. And when you divide negative 80 divided by positive 16, you'd get a negative 5, and the t's cancel out. And then if you just kind of look ahead a little bit to some of them, sometimes you can get a real easy clue of what the GCF is. So 0 equals 16t plus 1 times t minus 5. All good with that? Let's solve. What does t equal? T could equal negative 1/16 or 5. We don't need a set yet because this is a story problem. We've got to answer the question. What does t stand for? Time in seconds. How long did it take for that javelin to hit the ground? Negative 1/16 seconds, sir. Is that how long it took? Yes or no? That's an extraneous answer. It is an answer to this algebra problem. It makes absolutely no sense for this story situation. That is extraneous. How long did it take for this javelin to hit the ground? 5 seconds. Here's a nice, neat sketch of that situation. The parabola looked like this. It started in the guy's hand. The guy's hand above the ground before we started. So do you see, at 0 seconds, it was already above the ground. And then it hit it at 5 seconds. But, see this? If it was continued on in a non-real life situation, would that parabola still cross the x-axis in 2 different places? But we have to throw this one away because it doesn't make any sense for this story. We've got a weird bit of information right here. I want you to squeeze the word initial in front of that word height. Then you and the pal read this thing, see if you can substitute some stuff in and set me up a nice little situation for this. But they've worded this problem poorly. So when it says where c is the height, make c be the initial height in feet. Here's the ground. You're going to bungee jump, right? So you start off some sort of platform. Something. You got to jump off something. This wouldn't happen. Why not? You would die. Why? It comes close, though. When you bungee jump, do you actually hit the ground? That's kind of the reason why you're bungee. We're going to come close to it, but not really hit it, correct? So when you bungee jump, you will jump up just a little bit, and then you'll start to fall. And usually about like here or so, that'll be like as far as you go. Then you spring back up and down and up and down and up and down. But this is the initial situation. Sound cool? Parabolic in nature. How high was this old boy, Juan's brother, when he jumped? 1,100 feet. Is everyone okay with that? And it says when he got here. Isn't that the point where this thing snaps back at? How high is that? 76 feet off the ground. And here's the basic formula for this situation. All cool with that. It says use this where c is the initial height in feet. what is the initial height in feet? Is it 76 or is it 1100? So I definitely know 1100 is going in here. Correct? And this stands for the height in feet at any given point in time. Do we know a height in feet that Juan's brother is at any given point in time? Is it 0? That would mean he's on the ground, correct? How high was he? 76. That's how long it took before the cord snapped back, right? At 76 feet off the ground, that's when it snapped back. We need to find the time in seconds in this situation. Is everyone cool with the substitution on that? Is this quadratic? Yes or no? Yes or no? Yeah. Is it equal to 0? Is it equal to 0? It is quadratic because the biggest exponent you see is a 2. 1100, take away 76. That is 1024. Awesome? Yes or no? I don't like the negative 16 in this situation. I just don't like that negative 16. What could I do to change that for me? So how about 0 equals 16t squared minus 1024? Is everybody okay with that? Let's go through the list. Is the a value 1? Nope. Is there a GCF that we could take out? Oh yeah, those are both even numbers. And take a wild guess, what would be the first number you would try to take out? A 16 would be the first try that I would want to take out, because that's the smallest number that I got in here. Does 16 go into 1024 evenly? And how many times? Oh, Daddy likes. Because now, this dude is meaningless to us, right? This 16 that got factored out has nothing to do with it. It doesn't have a variable with it. Daddy likes him a lot. That's two guys being subtracted from each other. Is the first guy a perfect square? Is the last guy a perfect square? And this was a subtraction problem. What are these called? That is not a perfect square trinomial. What's it called? A difference of squares. It factors into conjugates of each other. What will those two conjugates be? T plus 8 and t minus 8. The square roots of these guys. Doesn't matter what order they're in. No. Now we can use the zero product property to solve. You mean nothing to me. You mean nothing. You have no variable. What could t equal in this first guy? T could equal negative 8. Or t could equal 8. Let's go back to my picture. Here's my picture. How long did it take for him to get to this point and spring back? Does negative 8 seconds make sense? So what you got to do, in your work is cross it out. That's an extraneous answer. 8 seconds is how long that puppy took. Fabulous? One more. A rainstorm for me. Every single one of you has passed the geometry course. What would you do to set this problem up? Yes, you are right. The question is, what do they give you? People said area. We got to go a little more trivial than that. What shape do we have? Rectangle. What do they give us about it? Area. Start with the formula. I guarantee you can remember the formula for area of a rectangle. What is the formula for area of a rectangle? Length times width. Which one's the length? Which one's the width? Who stinking cares? There's 3 variables in this guy. Do we know the area? Let's substitute in from left to right. Do we know the area? What is it? 432. Do I know the length? Sorta. Do I have a representative for him? X plus 4 would be fine, or you could have done x plus 2. Doesn't matter which one's which. Now watch this. Tell me what's wrong with this. If I put x plus 4 in for the length and I put times x minus 2 in for the width, what's wrong with that? I didn't what? I didn't use parentheses. The only thing getting multiplied together in this side is the 4 and the x. We don't want to take just the 4 times the x. Don't we want to take the entire length times the entire width right there? You all cool with that? Awesome. Isn't this like two dudes times each other already? So does that mean that x should equal 4 and x should equal 2? Can we just solve it right now by using the zero product property? Can we use the zero product property to solve this situation? Why not? Why can't we use the zero product property? It's not equal to 0. We probably better FOIL this out first. And then once you've got it all FOILed out and nice and expanded, being how it's a quadratic, especially since it's got an x to the first and an x to the second in there, you probably better get it equal to 0 after that. And a negative 8 and a negative 432, isn't that a negative 440? Yeah? Now, we'd like to try to solve this by factoring. Let's go through the list. Is the a value 1? Yes. Another thing to check for, though, if it's a perfect square trinomial, because that would be like a double advantage. Is the first guy a perfect square? Is this guy a perfect square? It can't be, because it's a negative number in the first place, and 440 is not a perfect square. But since the a value is 1, we can do it short and sweet. We don't need to do frowning face. I need to find two numbers that multiply together to be a negative 440 and add together to be a 2. How close together will those numbers be? If you start by doing this, 1 and 440, aren't those 339 apart? How close together do these numbers have to be? 2 apart. Are you with me on that? Start playing around with numbers that are 2 apart that probably multiply together to be 440. See if you can find. They have to be 2 units apart. That's what the whole trick is. I would have loved to have shown you that last week, but we just didn't have enough factoring experience to kind of get that. 20 and negative 22, is that right? Ooh. But those are the right two numbers with the wrong signs, correct? If my pen wouldn't freeze here. Are we all good with those? Let me show you another super secret if you get a little more advantage. When they're really, really close to each other, aren't 20 and 22, if you just ignore their signs, aren't they really, really close to each other? They're 2 apart. You got to find two numbers that multiply together to be 440 that are that stinking close. Watch this. Maybe. What did I do? I square rooted it. Aren't those like two numbers exactly the same that multiply together to be 440? That puts me in the ballpark of where I need to be. I need to be in the 20s. Close to 20, close to 21, something like that, because I just figured out what two numbers exactly the same multiply together to be 440. I know they couldn't be exactly the same. They had to be 2 apart, but I got 20.9. That means my first guess would be 20. 20 times what equals 440? Oh, 22. Boom. Maybe you can handle that. Maybe you can't. You know as much as I do. This sucks to find those two numbers. If you can start learning more and more secrets of how to do it, then we can roll with it. So we got to now factor this. That would be x minus 20 times x plus 22, correct? So let's solve. What could x equal? 20 or negative 22. Those are our two algebraic answers. Do they both make sense? Maybe, maybe not. Just because you get a negative doesn't mean you have to throw it out. I'm going to repeat that. Just because you get a negative doesn't mean you have to throw it out. You must substitute back in and see if the resulting length is positive or negative. If you put a negative 22 in here, what's a negative 22 plus 4? It's a negative number. Can you have that for a side length? No. So x equals 20. Just because you got a negative x value doesn't mean it's got to get thrown out. You've got to substitute it back in and see if it works. Now, what did they ask us to find? the dimensions of the rectangle. We found x. Now put 20 back in, so label it like this, dimensions. Maybe dimensions, colon. If we put 20 in right here, my bad, 20, how much would that be? 24 what? By, if we put 20 in up here, by 18 inches. One real quick way to double check you did it right. It shouldn't 24 times 18 turn out to be 432. Isn't that like what we did in the first place area of this rectangle? So x equals 20, and the dimensions were 24 inches by 18 inches.